Hello, my name is Vikrant Singh and I am currently pursuing Masters in Construction Engineering and Management at CEPT University. The title of my thesis is Climate Resilient Infrastructure and Strategies for Green Highway Construction and Maintenance. Before I delve into the details of my study, I would like to express my sincere gratitude to my guide, Mr. Sagar Deshmukh sir, whose expertise and guidance have been instrumental in shaping this research. His mentorship has not only helped me navigate the complexities of subject, but has also inspired me deeply throughout my academic journey. The motivation behind this thesis stems from a pressing need to address the environmental challenges posed by a conventional highway construction and maintenance practices. As we witness the increasing impacts of climate change, it becomes imperative to shift towards more sustainable and resilient infrastructure solutions. In this presentation, I will discuss the innovative strategies that can be implemented to construct and maintain highways that are not only less harmful to the environment but also capable of withstanding the adverse posed by a changing climate. These strategies include the use of eco-friendly materials, energy-efficient technologies, and methodologies that enhance the longevity and durability of road infrastructure. The concept of climate-resilient highways extends to ensuring that the highway infrastructure remains functional and safe under a variety of climatic stresses, thereby reducing disruptions, economic losses, and risks to human safety. Background on climate impacts and its change says that in India, the impact of these global changes is both profound and uniquely challenging. Our country is experiencing significant variability in rainfall patterns and a rise in temperatures. The frequency of extreme weather events has escalated, endangering our communities and livelihoods. Such shifts are not merely inconveniences but are disruptions that threaten the fabric of our society. Perhaps most critically, the rise in sea levels poses a specific threat to India's extensive 5,700 kilometers coastline, escalating the impacts of cyclones and storm surges. This is not just about losing stretches of beach, it is about the displacement of populations, the destructions of property, and significant disruptions to ecosystem and biodiversity. The economic stakes are extraordinarily high. In recent memory, Cyclone Hudhud in 2014 resulted in losses amounting to approximately $11 billion. Similarly, the 2014 floods in Jammu and Kashmir led to immediate economic losses estimated at 570 billion rupees. These are not isolated events but markers of a disturbing trend that highlights the vulnerability of our economy to climate-induced disaster. Moreover, approximately 85% of India's geographical area is prone to one or more natural hazards, including floods, droughts, and earthquakes, further exacerbated by climate change. This vulnerability presents not only a severe risk to life and property, but also to our development goals and economic aspirations. Need for climate-resilient highways includes current standard based on historic data, climate impact on highways, economic and functional importance, vulnerability to extreme weather, existing guidelines and the need for enhancement and policy gap. Overview of India's transport includes contribution to GHG emissions, dominance of road transport, and projections and concerns which includes the transport sector contributes 14% of India's total energy related to CO2 emissions, making it the second largest source after electricity generation. A significant 88% of these emissions come from road transport, primarily due to its reliance on petroleum products. In 2012, road transport used 66% of all diesel and 99.6% of all petrol consumed in the country. Future projections indicates rising in CO2 emissions under the current trajectory, with major contributions from the construction, maintenance, and operation of national highways. The pie chart shows that share of different sectors in CO2 emissions, and below pie chart shows share of different transport modes in which road is at 88%, civil aviation carries 7%, and railways 3%. As shown in flowchart, I have done extensive literature review based on historical development and global adoption, which includes evolution from aesthetics improvements to integration of high-tech features and global trends in adoption. Further, there is core principle of green highways, which includes environmental protection, ecosystem management and conservation, resource efficiency, and economic benefits. Further, there is challenges in implementation, which includes legal and regulatory barriers, technological and physical challenges, financial constraints, cultural barriers. Later, there is impact of climate change on highways, which includes climate stresses and impact on highway infrastructure and operations. Further, there is climate vulnerability assessment methodology, which includes study examples with key steps and relevance tools used. There is green highway practice and sustainable technologies, which includes use of recycled materials, sustainable construction techniques, porous and permeable pavements, and last but not least is green highway rating system, which includes overview of existing systems, importance of life cycle assessment. We concentrated our efforts specifically on Gujarat due to its unique geographic and climatic challenges. Focusing on critical aspects of infrastructure over the next decade, our extensive literature review revealed global best practices in green technologies and resilience strategies, providing a robust foundation for our strategies. In assessing vulnerabilities, we collected data on highway conditions, environmental factors, and historical climate impacts, followed by detailed risk analysis and vulnerability mapping to pinpoint critical areas needing immediate attention. Our formulated interventions, such as enhancing drainage system and integrating heat-resistant materials, are tailored to meet these challenges head-on. Our exploration for green technologies like permeable pavements and solar roadways led to a thorough assessment of their sustainability and practical viability. Here are some of the green construction technologies such as reclaimed asphalt only geosynthetic. Reclaimed asphalt pavement consists of asphalt and aggregates removed and reprocessed during pavement, resurfacing or reconstruction.
properly processed RAP can be used as high quality aggregate for coarse bituminous layers. Some of the key advantages are conservation of resources, reduction in waste, energy efficiency. Its savings in CO2 compared to hot mix asphalt mixture made with fresh aggregate. The hot mix asphalt mixture containing 30% of RAP by weight saves about 16% of energy and 20% of CO2 per ton. Similarly, for geosynthetic, they are the products used in geotechnical and civil engineering applications where at least one of the components is made from a synthetic or natural polymer. They can be in the form of a sheet, a strip, or three-dimensional structure, and they can be knitted, non-woven, or woven. Some of the key advantages are extended payment life, increased bearing capacity, faster construction, environmental benefits. The GHG emission for a 1 kilometer road without using geosynthetics is about 730 ton of CO2 emission and 650 ton of CO2 emission for a road that is constructed using geosynthetics.
This section of research analyzes the Ahmedabad-Bagodara highway section, focusing on the potential application of green technology like recycled asphalt pavement, solar LED lighting, geosynthetics, warm mix asphalt. The study evaluates how these technologies can lower carbon emissions and enhance environmental sustainability, contrasting with the existing resource-intensive infrastructure. Here are the comparisons shown using conventional material and recycled material. This analysis confirms the environmental benefits of the using recycled asphalt pavement in road construction. The substantial reduction in carbon emission demonstrated by reclaimed asphalt pavement approach not only mitigates the environmental impact of road building but also presents a scalable model for sustainable infrastructure development. Comparing high pressure sodium lights to the solar LED lights, solar LED lights uses 49% less electricity and emit 51% less CO2 than high pressure sodium lights. Switching all 1334 lights to solar LEDs reduces annual CO2 emission by over 607 metric tons. Comparing geosynthetic with non-conventional method, geosynthetic pavement construction reduces carbon emission by 45,671.5 kg of CO2, a 38.9% decrease. This method uses geosynthetic materials to improve soil and reduce reliance on natural aggregates, lowering emission from extraction and transportation. This section of thesis outlines the data collection process used to identify vulnerable sections of National Highway network in Gujarat.
a state prone to floods, earthquakes, and cyclones. The approach integrates various hazard data layers with a highway map to assess the risk from climate-related events. Here, the image shown of earthquake hazard map, flood hazard map, wind hazard map, and there is overlaid of national highway network. The analysis process done is data acquisition, further preparation of data, overlaying of GIS, uh, and analysis and classification. Here are the list of vulnerable national highways in Gujarat. Some are NH 754K Lakhpat to Khavda, NH 927C Rapa to Samkhyali. Similarly, NH 341 Khavda to Bhuj to Anjar, NH 68 Bhava to Wow, NH 160 Tharad to Dhanera, NH 47 Bagodara to Sarkhej to Adalaj, NH 48 Majra to Prantij to Vijapur, and similarly others. Here are some of the interventions based on the regions. Considering the region as desert, plains, coastal areas, if there is climate pressure of high temperature, these are the impacts on highway elements. Pavement of softening leads to rutting and shoving, buckling and heaving pavement joints, increased cracking enhances susceptibility to water damage and potholes. Similarly, its engineering interventions are structural reinforcement, moisture barrier, high temperature resilient asphalt, micro surfacing technology, patch holes with various asphalt mixes to stop water. Similarly, considering the region as desert plains, coastal areas, and if climate stressor is intense rainfall or extreme precipitation event, impact can be increase on pore pressure, erosion and subsidence, infiltration of rainwater, water overflow damage, clogged drainage system, and its interventions are chemical soil modifier, soil stabilization, erosion control, and flood management. Here are some of the images shown from various interventions on site. Here there is use of glass grids in Cochin International Airport. Similarly, here is planting of shrubs and trees in a phased manner for erosion control, and geotextiles in road construction and prevention of soil subgrade erosion for grade stabilization at Jejuri Morgan. Use of recycled asphalt pavement in road construction reduces CO2 emissions and supports climate change mitigation by minimizing the environmental impact of material extraction and property processing. This practice promotes sustainability in infrastructure, and it is encouraged to policymakers, urban planners, and construction companies to enhance environmental sustainability in their projects. Further, there is geosynthetic. The use of geosynthetics in pavement construction reduces carbon emissions and aligns with sustainable construction practices. This method not only lowers the carbon footprint but also enhances the durability, cuts maintenance costs, and improves performance in harsh environments, promoting the adoption of innovative materials and technologies. Warm mix asphalt offers a more environmentally friendly alternative to hot mix asphalt due to its lower diesel consumption and CO2 emissions. Adopting the warm mix asphalt supports sustainability in road construction by reducing greenhouse gases and aligning with industry sustainability goals. Stakeholders from planners to engineers should prioritize warm mix asphalt in their projects to capitalize on its environmental and economic benefits.
Adopting solar LED streetlights significantly reduces power consumption and carbon emissions, supporting sustainable urban development. This transition not only aligns with global climate change efforts but also offers long-term cost savings. Municipalities should prioritize solar LED technology in new installations and upgrades to enhance urban infrastructure sustainability.